All right, using transformations to graph. Example 1. All right, we have the equation y equals 4 times the cosine of x. So if we want to graph this, notice that we have an a value. This is called the amplitude. Of 4. So if you'll recall, the cosine of 0 radians is 1. So the cosine of 0 radians is 1. And 1 times 4 is 4. If we were to make a table, we'd have our input value, and then we would have our output value. So again, 0 radians, be 4 times cosine of 0, 1. So 0, 4. That would be our first point. Okay, the next one on the unit circle, we'll use pi over 2. Okay, the cosine of pi over 2 is 0, and 4 times 0 is 0. So at pi over 2, we are at 0. Pi, looking at your unit circle, the cosine of pi is -1 times 4 is -4. 3 pi over 2, cosine of 3 pi over 2 is 0, times 4 is 0. And finally 2 pi, we're back to the beginning. The cosine of 2 pi is 1, times 4 is 4. Okay, so notice the orange is your parent function, y equals the cosine of x. Notice how it was vertically stretched. This is your amplitude. So when you're looking at a graph, if you want to determine the amplitude, look for how high and how low it goes. It's the absolute value of that number. So the absolute value of 4 is 4. The absolute value of -4 is 4. So the amplitude for this graph is 4. All right, let's take a look at another example. Okay, let's take a look at this one. We have the cosine of x plus 1. Here we have a vertical translation of 1 unit. So basically, we're going to take the parent function and we're going to translate it 1 unit up. So let's see what that looks like. Starting off, cosine of 0 is 1. 1 plus 1 is 2. Cosine of pi over 2 is 0. 0 plus 1 is 1. Cosine of pi is -1. -1 plus 1 is 0. Again, cosine of this is 0 plus 1 is 1. Cosine of 2 pi is 1. 1 plus 1 is 2. And let's graph this. Alright, so 0, 2, pi over 2, 1, and so on. Now if you compare that to the parent function, remember the parent function is just 1 unit down from there. It was translated 1 unit up. Okay, next example. Okay, example number 3. Notice this time we have the sine function. So I went ahead and I graphed the parent. Y equals the sine of x. So we can see the transformation a little bit better. Notice that we are subtracting pi. inside the parentheses, if you'll remember, this represents a horizontal translation. In this case, we're subtracting pi, so we're going to the right pi units. Okay? So basically, once you have this parent, we can translate everything to the right pi unit. So this point would go here. That's pi units over. So that's 1, 2, 3, 4, 4 squares. So this one would go over pi units. This one would go over pi units. Uh-oh. I think I didn't plan well enough on my graph. And this one would go over, you can barely make it on there. So we would be looking at something like that. And this would be the graph for this function. So what we have here is, if I write my function table and I plug 0 in, we'd have the sine of 0 minus pi, or aka the sine of negative pi. Just recall, negative pi would be going clockwise around the unit circle. This would be negative pi. The sine of negative pi would be 0. So when x is 0, y is 0. So we'd be right there. So pi over 2 would be the sine of pi over 2 minus pi. So pi over 2 minus pi would be negative pi over 2. And negative pi over 2 would be down here. And the sine of negative pi over 2 is negative 1. And so on and so forth. And we can keep on going, and you can see how it makes our sine graph. All right, looking at example 4, notice here we have a horizontal stretch or compression. Well, what we're going to determine here is, because this is going to affect the period for cosine, recall that the period for cosine, and in your textbook they use the letter T to represent period, but for the parent function the period is 2 pi. Okay? In this case, the period is changing. Anytime you have a horizontal stretch or compression, your period is going to change. So to determine how much it's changing, we're going to use a formula here, and it goes like this: 2 pi divided by omega, and this is omega. So let's plug it in and see what we get. Okay, plugging pi over 2 in for omega, we get 2 pi over pi over 2, and you multiply by the reciprocal, and you get 4. Well, we're going to compare that number to the period for cosine, which is 2 pi, or 6.28. Notice the period got shorter, which means that the graph has become compressed. So we have a horizontal compression. Remember, if this number is bigger than 1, we have a horizontal compression. If it's less than 1, if it's a decimal between 0 and 1, we have a horizontal stretch. Remember, it's the opposite of vertical stretch and compression. So So we have a horizontal compression. Now to graph this. So 4 represents the period for this function. Remember, that means that the graph cycles every 4 radians. Okay? So we're going to go ahead and label our graph. So starting with 0, 1, and we can spread it out a little bit so it's not too tight here. 0, 1, 2, 3, and 4. Okay? So at 0, we have the cosine of pi over 2 times 0. So the cosine of 0, which is 1. So I'm going to go ahead and put 1 up here, spread it out a little bit. The cosine of 0 is 1. Then the cosine of, if we plug 1 in, pi over 2 times 1, cosine of pi over 2, which is which is 0. Plugging in 2 in here, we get the cosine of pi, which is negative 1. Plugging in 3 in here, cosine of 3 pi over 2, which is 0. And 4, plugging 4 in, cosine of 4 pi over 2, or 2 pi, is 1. Notice we're back to where we began. So our period is 4. And that is the graph. That is the graph for that equation. Okay, I went ahead and did the table for you so you can kind of see where I got my numbers from. I plugged the 0 in, multiplied, plugged the 1 in, multiplied, plugged the 2 in, multiplied, and then I found these values on my unit circle. Okay? Okay, determining the amplitude and period from a function. Amplitude is pretty straightforward. It's your A value on the front. We have an amplitude of 9/5. Now to determine the period, remember the variable we use is t, and the formula is 2 pi divided by omega. So 2 pi divided by negative 3 pi over 2. Okay, doing the math. Okay, so we're doing the math here, but I remembered that cosine is an even function, and if your input is negative, then your output is positive. So since my input is negative, I went ahead and just rewrote this as a cosine of a positive because it's an even function. So that negative, I took that off, so I'm doing 2 pi divided by 3 pi over 2. Notice the negative is gone because it's an even function. Dividing, we get 4/3. And that would be our period. That's how long it takes for this function to repeat itself. Okay, and our amplitude is 9/5. Okay, your assignment in the book is on page 415, and we're going to be doing 21, 27. I think that would be a good one. Let me see. 1 second. No, that would not be a good one. Let's do 29 and 35.